Hello guys, I'll be solving Leetcode's daily problem, that is create binary tree from descriptions. So like we have been given a vector, that is descriptions vector, and it contains three informations: the parent, the child, and a boolean variable, that is left. And if is left is goes to 1, that child is a left child, and if is left is goes to 0, then that child is a right child. So what's the mental model of this question? Like how will you think of this question? Okay, so the first thing would be like to have a hash map. A hash map for storing like all the details of the parent, child, and like everything. Sorry for the disturbance, that was a call. uh, Leave apart that. So first of all, I'll create a map, but that map will look like uh, of an integer and a node. Now why integer and a node? Because we have been given like that description vector is unique, and all the elements, like all the nodes, will have a different value. So I'll create a map. Now why a map is needed? Cause like descriptions do repeat. Cause see, 20 is a parent here, but like 20 is again a parent, but now 20 is a child. So now we need to track like 20 has occurred or not. So we'll create a map that is integer and node. Okay, so I've created a map, and like I'll create a loop so that we can traverse over the descriptions. Okay, and so there's a braces problem. Okay, so first of all, we'll check the parent. Now parent would be d of 0, like our iterator is d. Child would be d of 1, and our is left is goes to d of 2. Okay, so first of all, we'll check that if we have encountered our parent as of now or not. So we'll check if the parent exists in the map. If not, then we'll create a parent. We'll create mp of parent is equals to new node. We'll create a new node, and what will be the value? Parent. Okay, as and like likewise, we'll also check for the child. In the next line, I'll check for the child. So I've checked for the child. If there is no child such that, so we'll create a child node also. And then since I've checked, now we'll connect them. Okay, so mp of parent, no, but we have to check like is left is equals to 1. That means that the particular child is a left node. So we'll connect mp of parent, that is our root node, it's left to mp of child. And if not, then we'll connect our mp of parent, that is our root node, it's right to the mp of child. Now since I told you in the start, like we have to make the binary tree using hash maps and like using all the logic, but in the end we have to return the root node, since it is asked for us to return the root node. Now how do we know which one is the root node? So a root node is a node which does not has a parent. So what I'll do, I'll create another set. I'll not create a map, I'll create a set now which will store the children value. Now, if 20 is a children, I'll store it in set. If 80 is a children, I'll store it in set. If 15, so likewise, I'll store all the children in the set. And the only node which is not a children will be the root. So 50 will not be stored in the set, and that is the basically your root, and I'll return that. So what I'll do, I'll insert the child value into the children set which I have. So I've inserted it, and after this loop, I'll just have a loop on the map again, and I'll check if there is any value that is not inside children. If there is any value that is p dot first, I'm checking p dot first because the like map has the first value as integer. So if children does not contains the p dot first, then we have to return mp of p dot second. Now p is a iterator, and like p is a iterator which has p dot first and p dot second. P dot first represents the value, and p dot second represents the your tree node. So I'll return I'll not return p dot second, I'll return mp of p dot first. Okay, so and after this I'll return null, cause like we cannot leave the return statement. Let's see if it runs. Okay, I've like messed up a bit. Is left, I have right I left. Okay, and what the hell, never mind. Okay, so now I'll submit this. And yes, this works. Now I'll analyze this also. Okay, so the current approach uses hash table, tree, and simulation, and even the suggested approach is the same. Now the key idea was constructing a binary tree from parent-child descriptions using hash maps to track nodes. Like, so everything is perfect. Okay, thank you.